Hello. Once again, you are welcome to Daz-Tuition. My name is Ernest Adazi. I'll be taking you through the fifth episode of our Thermodynamics tutorials. Today, we are going to try something different. Remember, the reference material is the textbook Thermodynamics and Engineering Approach by Eunice Sengel and Michael Boyles. Yeah. So with this, today we are trying a bit. The questions remember if you followed us from the first episode, we start with some concept, and then we just went through the difference between absolute and gauge pressure, and then atmospheric, and then we went ahead to look at the manometric analysis. Yeah, today we are just looking at we're going to look at the piston cylinder arrangement. Okay, so this is the fifth episode, and the problem statement is this. It's just straightforward, and here we are going to apply the knowledge you gain from statics or engineering mechanics here. Okay, this is how they are intertwined, thermodynamics and that. So basically, engineering courses are linked. Okay, once you understand one, you apply that in the next course to solve a problem. So we are going to see that today. So we have a gas. Okay, let me use this highlighter here, the laser pointer. We have a gas, okay, in this tank, and we have a frictionless piston, okay, and then we have a spring connected to the piston, and also atmospheric pressure acting on the piston. The piston has its own mass, okay, it's not weightless. I get it. So we are going to look at the weight on the gas. We are going to look at the weight. Remember, weight is force. We are going to look at the force exerted by the spring on the gas, and then the force exerted by atmospheric pressure on the gas. Now, it means that if I know the force in the spring, I need to know the area here, right? If I know the area, I can relate the force to the pressure, because I know that pressure equals what? Force over what? The area in this case, or the force per unit area. If I look at atmospheric, I can also look at atmospheric force, okay, in terms of, let's say, the pressure being equal to what? F over the area, right? Good. So we're going to see that. Now, it is clear that they've given the mass of the piston to be this, and then the cross-sectional area to be this in centimeters. Remember, we have to convert it to what? Meters, right? So it will be point to the power minus 4, right? So we have 0.0035 meter squared. Okay, that's what is going to be the area. Now we are going to see how best we can solve this problem. All right, okay, so the spring is 150 newtons, and then atmospheric is 95 kilopascal. Okay, within. Okay, we are to determine the pressure inside the cylinder. Now, take note that we are going to look at the free body diagram, and we are going to consider the piston. Because if I look at the piston, I have a piston here, and on this piston, I have the weight of the piston, W here, and I have the force due to the spring, which is 150 newtons. Now remember, I have force due to what? Atmospheric pressure. So distribution here. Okay, atmospheric pressure distribution on the piston surface. And now finally I have, so this is, let's say, atmospheric. So all these forces are acting on the gas. So now on this piston, the gas tends to what? Oppose that. So that one too, because it's a gas, we have the forces or the pressure distribution there. So I have force of gas, right? But remember, pressure equals what? F over A. Is that not it? So if I consider this and I say maybe upward forces positive and downward forces negative, the sign conversion, I can say that from this balance, I can write the force balance equation as F gas, okay, positive, minus F spring is negative because it's going down, minus force due to atmospheric, okay, minus the weight. And you know weight is what? mg. So that's where we have the mass coming in, and then g is simply the acceleration due to gravity, 9.81 meters per second square. So we have this. So now we equate this to 0 because this is the force balance. So if I'm to find anything at all, remember, if I make force the subject from this equation here, I'm going to have F being equal to what? PA. So if I have F being equal to PA, remember A is constant. A is just the piston surface, okay? It's a piston cross-sectional area, so it's the same. So I can rewrite this equation as PG of gas times area, which is constant, area of piston, okay, minus, for the spring is just there, so we have 150, okay, newtons, all right, minus PATM times area P, okay, minus mg, should be 0. So since I'm looking for the pressure within the within the tank, we are to determine the pressure, we are looking at the PG. So making that a subject, we have P gas being equal to what? Remember there's A here. This is the P. Okay, it's correct now. So we have PG being equal to 150 plus PATM AP plus mg all over what? A. So if I do the substitution correctly, I should be able to get my my pressure within the gas, and that will be the final answer. Okay, so I've typed everything here for clarity's sake so that you know what to do. So P atmospheric, we know this value to be this. We know AP to be this, and we have to change it to, for centimeter squared, to 0.0035 meter squared. So we base on this, do the substitution, and obtain the final answer. So if I clear the surface, or sorry, the board or the screen, and try to go with what we have, we just do the analysis in a similar approach so that you understand. Okay, now remember, we are saying we are asked to find the gas, the pressure of the gas, okay, within the tank. So the free body diagram, we are going to consider what? The piston. So if we take the piston, okay, if we take the piston and then we consider the forces, the first one is the force due to the spring acting on that. The second one will be due to the atmospheric pressure, okay. The third one will be due to the weight of the body. It's supposed to act in the middle, okay. All right. Then we have the pressure of the gas, P acting upward because it tends to push what? The piston up against the spring, against the weight, against the atmospheric pressure. So the force balance, like we did before, has to do with what? This PA, upward force, equals what? Downward forces, right? So PATM times A multiplied by what? The force spring, okay, the spring force plus the weight. So if we rearrange for P, we end up having this, okay? Are we following? Remember, it's PA over A, so that's why it's cancelling out, all right? So I'll just put in these values, and then I have the formulation 35 times 10 to the power minus 4, like we did before, 0.0035 meters square, and then based on the substitution, we'll end up getting 146.83 kilopascal to be our pressure within the tank. So this should tell you that the gas is under pressure, kind of trying to push up, right? Okay, all right. So that is it for today. Thank you once again for your time. If you have any comment, try to leave it, or if you have any information or question, just leave it in the comment section, and try to subscribe for me, okay? So that you don't miss my updates. All right, good. All right, have a good one.